In today's video, we're going to use prime factorization as an approach to finding the square root of a large number. Then we're going to extend our thinking to find a cube root of an even larger number using a very similar technique. We hope to gain some insight into how prime numbers act as fundamental building blocks. And we also want to gain a greater understanding of the deeper connections between some of these numbers. Let's get started. Let's get into our first problem then. We'd like to find the square root of this number, 27 multiplied by 147. And to do this, we're going to lean on prime factorization quite heavily. So first of all, let's have a look at the prime factorizations of both of these numbers. So for 27, first of all, we can break it into 9 times 3. We circle 3 because it's a prime number, and then we can do the same thing for 9, breaking it into 3 times 3, leaving us with the prime factorization that 27 is 3 times 3 times 3, or 3 cubed. Same thing then for 147, but with a little bit of thinking, we can see 147 is 49 times 3. So 49, 3 gets circled again because it's prime, and 49 can only be broken into 7 times 7. So our prime factorization then for 147 is going to be 3 to the power of 1 times 7 squared, or 7 to the power of 2. Okay, well this is pretty nice so far. But what we'd like to do now is think about when we multiply these two numbers together, what happens? And a bit of thinking about index laws should remind us that when we times two numbers together, so 27 multiplied by 147, well, all we're doing first of all is just multiplying their prime factorizations together. So 27 is the same as 3 cubed, and 147 is the same as 3 to the power of 1, multiplied by 7 to the power of 2. That's 27, that's 147. Thinking about index laws then, we just add the powers. If the base is the same, 3 to the power of 3 times 3 to the power of 1 will give us 3 to the power of 4. And in this case, the 7s, well, they only are present in 147, so we just keep our 7 squared. What this is telling us then is that the number we're thinking about, 27 times 147, can be written as 3 to the power of 4 times 7 squared. Now we'd like to really think about how we get the square root of this number from its prime factorization. And what we need to do is, from this number, pull out two identical smaller numbers with the same prime factorization. Here's how we should approach this then. If we write this out in full first of all, so 3 to the power of 4, we've got 3 times 3 times 3 times 3, and we've got multiplied by 7 squared. So times 7 times 7. What we want to do is separate two of these out into equal numbers. And what's really nice for us is that we have even powers of everything. So we can split them neatly in half. That's what we need to do. I'm going to take 2 3s and 1 7 for one number. So we're going to have 3 times 3 times 7. And in a different colour, I'm going to take 2 3s and 1/7 for another number. So times 3, times 3, times 7. Now both of these two are the same thing, and we've split these powers up into two nice chunks. So what we can do now is figure out, well, what actually is this number? Because this must be the square root of 27 times 147. It's the same number multiplied together to get us our original number that we wanted. Well, 3 times 3 times 7 is 9 times 7, which is 63. And obviously here we had 63 as well. What this tells us then is that our square root of 27 times 147 is 63. So let's just write that down. Our square root is 63. We've proved that by being able to take out the same number twice from that prime factorization. So now let's apply our thinking and our method to a more difficult problem. We would like to find the cube root this time of a number 30 multiplied by 135 multiplied by 180. Like we did last time, let's start off with a prime factorization for each of these numbers to think about what the larger number is built up from. So we can go a little bit quicker through this time. We've got 30, which factorizes into 5 and 6 into 2 and 3. So 30 can be written as 2 times 3 times 5. 135 can be factorized into 5 and 27, and 27 to 9 and 3, and then 2 more 3's here from 9. So we get the prime factorization of 27 as 3 times 3 times 3 times 5. Okay, and lastly we need to do the same thing for 180. I'm going to go for 30 and 6. 30 goes into 5 and 6, 2 and 3, and 6 into 2 and 3. So writing out 30's prime, so 180's prime factorization, 2 times 2 times 3 times 3 times 5. So let's write that down. 2 times 2 times 3 times 3 times 5. Okay, well now we've got prime factorizations for each of these three numbers. We can think about when we multiply them together, what happens? So our bigger number, our largest number of all, which is 30 times 135 times 180, we've got all of these prime factors which are all multiplying together. So let's write out what we've got. We've got 2 times 3 times 5. I might have to go onto a new line because it's going to be quite long. 2 times 3 times 5. I'll put it in brackets to be really clear where each of the factors are coming from. Our 135 gives us a 3 times 3 times 3 times 5. And then our 180 gives us a 2 times 2 times 3 times 3 times 5. 2 times 3 times 3 times 5. Okay, just about managed to squeeze all of our prime factors in there. So when we multiply these all together, we can see actually there's only 3 prime factors to worry about. A 2, a 3 and a 5. So we're going to have some powers of 2 multiplied by some powers of 3 multiplied by some powers of 5. And counting them up to see how many we've got, well, we've got 1, 2 here, and 2 more over here. So that gives us 3 powers of 2. Looking at our powers of 3, we've got 1 here, 1, 2, 3 here, and 2 more over there. So that's 6 in total. And our powers of 5, we've got 1, 2, 3. Well, if you're thinking a bit further ahead at this point, what's really good for us is that each of the powers is a multiple of 3. That comes in handy because for a cube root, we want to split these powers 3 ways equally. So what we'd like to do then, thinking about our cube roots, is take each of these, so we're going to have 2, 3, and 5, and split them 3 ways equally. Because we've got some number here that gets cubed to make our larger number. Well, 3 split 3 ways is just going to give us 1. 6 split 3 ways will give us 2. And 3 split 3 ways here will give us 1 for the 5s. So what we've got then is 2 to the power of 1 times 3 to the power of 2 times 5 to the power of 1, all cubed, will give us our original largest number that we wanted. And this makes real sense looking back, because if you cube a number, well, what you need to do is multiply the index power by 3. 1 times 3 is 3, 2 times 3 is 6, 1 times 3 is 3. It all makes sense. Last step for us then should be thinking, well, what actually is this number that we're cubing? So I'm just going to switch to a different colour. 2 times 3 to the power of 2, well, that means 2 times 9, which is 18, times by 5 will give us 90. So the number inside those brackets is actually 90. In other words, the cube root of this number that we're looking for is 90. So let's finish off with saying that really clearly. The cube root is 90.